Hello, welcome to the fourth video of my Algebra 1 series. Today we will be learning Systems of Equations Part 1. In the second part, which I will cover in the next video, we will finish learning how to convert different forms of linear equations. Before we move on to the content, let's take a look at the answers to the challenge questions. We are being asked to identify the form of each equation. Let's start with number 1. 3x plus 2y is equal to 15. Because this is in the form of ax plus by is equal to c, we can identify this equation as standard form. Now for number 2, y is equal to 2x plus 5. This is in the form of y is equal to mx plus b, so we can tell that this equation is in slope-intercept form. Number 3, 4x plus 2y is equal to 9. This is also in the form of ax plus by is equal to c. Therefore, it is also in standard form. Number 4, y minus 3 is equal to 4 times the quantity of x minus 2. Now, this is in the form of y minus y1 is equal to m times x minus x1. Hence, it is in point-slope form. Number 5, y is equal to 5x plus 3. This is in slope-intercept form, as it also takes the form of y is equal to mx plus b. Number 6, 2x plus 5y is equal to 12. This is in the form of ax plus by is equal to 3c. Therefore, it is in standard form. First, what does it mean to solve a system of equations? Well, it means that we're trying to find a common point that the two equations intersect at on a graph. There are two methods to solve a system of equations. The first method of solving a system of equations is by substitution. Through this method, we are substituting variables from one equation to another in order to get the values of both variables. Let's take a look at this example. We are being asked to find the point of intersection of the equations 8x plus 4y is equal to 12 and 4x plus 2y is equal to 24. First, we have to solve for a common variable in each equation. Let's take y for example, and let's start by solving for y in the first equation. Let's get the y term by itself. To do this, let's subtract 8x from each side. This leaves us with 12 minus 8x is equal to 4y. Now let's isolate y by dividing both sides by 4, leaving us with 3 minus 2x is equal to y. We have successfully solved the first equation for y. Now let's do the same thing for the second equation. To get the y term by itself, let's start by subtracting 4x from both sides of the equation. Doing so will leave us with 24 minus 4x is equal to 2y. Now, to get y by itself, let's divide both sides by 2. Thus, we have solved for y in the second equation as well, as 12 minus 2x is equal to y. The second step to this process is that we have to make the equations equal to each other and solve for a variable. In this case, the variable we are solving for is x. We start with 3 minus 2x is equal to 12 minus 2x. Subtracting negative 2x from both sides leaves us with 3 is equal to 12. Obviously, 3 does not equal to 12, which means that there is no solution to the system of equations. Let's take a look at another example of substitution. In this case, we are being asked to find the point of intersection of the lines y is equal to 6x minus 11 and minus 2x minus 3y is equal to negative 7. Since y is already solved for us in the first equation, we can just plug that corresponding value for y into the second equation to get our x value. Doing so will give us negative 2 minus 3 times the quantity of 6 minus 11 is equal to negative 7. Let's distribute. We now have negative 2x minus 18x plus 33 is equal to negative 7. Now, let's get like terms onto each side of the equation. This leaves us with negative 20x is equal to negative 40. Now, let's divide both sides by negative 20 to get x by itself. Therefore, x is equal to 2. Now, let's plug that back in onto one of the original equations and solve for the y value. In this case, I have chosen the first equation just because it seems easier to work with, but you can choose whichever equation you feel more comfortable with. We have y is equal to 6 times 2 minus 11. 6 times 2 is equal to 12. So now we are left with y is equal to 12 minus 11. Therefore, our y value is equal to 1. The confirmed ordered pair solution to the systems of equations is 2, 1. Another method of solving a systems of equations is through elimination. We can eliminate a variable to solve for another one. Let's see how through this example. Here we are being asked to solve the system of 4x plus 8y is equal to 20 and negative 4x plus 2y is equal to negative 30. We can add these two equations to cancel out a variable, in this case, x. Adding these two equations leaves us with 10y is equal to negative 10. Therefore, y is equal to negative 1. Now let's substitute this value back onto one of the original equations. Doing so will give us with 4x plus 8 times negative 1 is equal to 20. If we choose to plug it into the first equation. Again, your choice on which equation you would like to plug this back into. Then we get 4x minus 8 is equal to 20. Let's add 8 to both sides to get 4x by itself. 4x is equal to 28. Dividing both sides by 4 will leave us to x is equal to 7. Therefore, a confirmed coordinate point that is a solution to the systems of equations is negative 1, 7. Here are some challenge questions to practice what we have learned in this video. As always, I will explain the answers to these problems in the next video. Solve the following equations by substitution or elimination. We will practice more of this concept in the next video when we finish learning how to convert forms of linear equations. Do you have any questions? Leave it in the comment section and I will get back to you later. Be sure to like and subscribe. Thank you for watching. I hope this helps. Bye!